All right, welcome back to our 10th lesson in our energy unit, and we are starting to talk about thermal energy. And our first lesson with regards to thermal energy is over heat and temperature. So a lot of times heat and temperature get confused as being one and the same, and there is a relationship between the two, but they are two very different things. So that's the focus for today's lesson. If you're just joining us, I would highly recommend going back and watching the other lessons prior to this one, because we have been talking about all things energy. We've gone through the different forms of energies, how energy can transform via the law of conservation of energy. We've talked about sound energy, light energy. We've talked about mechanical energy and how that's comprised of kinetic and potential energy. We've talked about waves and how they relate to energy. Specifically, we looked at electromagnetic energy. So we are just moving right along. Now, our heat energy lessons will be comprised of several different smaller lessons. So this first one's sort of an introduction to heat and temperature, and then we'll move through how heat travels, and ultimately we'll get to something called specific heat capacity. So if you have me in class, you're going to do, or you have done, this little CER investigation where we stick glow sticks in different colors, different temperatures of liquids to see what happens. And one of the things that we noticed is when we put the glow sticks in the really hot water beaker, they glowed brighter than the glow sticks that were in the cold liquid water. And so I ask you to think about that and write a CER on that. So hopefully you came up with the idea that because the molecules move faster in that hotter water, it transfers that energy to the glow stick, which creates more kinetic energy in those molecules in the glow stick, which then we see as a brighter light. So that's what's going on in there with regards to that activity and how it relates to energy. All right, so be sure to get down all of this information in your notes. We have not yet talked about matter and chemistry, but I'm starting to introduce you. We've talked about this several times. Matter is made up of atoms, and all the universe is made up of matter and energy. So it's a good time to introduce matter and how it relates to energy. The particles of matter are in constant motion all the time, whether we're talking about solids or liquids or gases. This is known as kinetic theory, which again, we'll talk about more in detail when we get to our chemistry units. Energy causes particles to always be in motion. So a lot of the times when we get to that unit in chemistry, students say, how is it that particles are always in motion? Well, the answer to that is energy. If there's no energy, then there is no motion. So energy powers a lot of what we see in both physics and chemistry. So I want you to pause the video and list 5 different temperature readings that we use or you use in everyday life. Now, your answers may have looked different or similar to mine, but there's a high chance that you could easily think of 5 temperature readings that you use in everyday life. Temperature is something that we focus on. We just maybe take for granted that it's such a huge part of our lives. So by definition, temperature is a measure of the average kinetic energy, remember that's moving energy, of all the particles that make up an object. So if I start waving my hands, I'm increasing my kinetic energy, and as a result, my body temperature is going to increase. Same thing, if I go run around my house or go run around the school building, I'm increasing kinetic energy. Those molecules in my body are going to start moving faster. As a result, my body temperature is going to increase. That happens with regards to any type of matter. So increased kinetic energy is going to be directly proportional to an increase in temperature. Now, if we want to measure temperature, we're going to use a device called a thermometer, which may not be something new to you. But if we don't know exact temperatures, we can use something more qualitative. So qualitative measures are like descriptive terms like hot or cold. So I could say that beaker is hot, or that chunk of ice is cold. So those are qualitative measures that are used to describe temperature. Of course, in science, we always like to use quantitative measures, which are going to be like our numerical values. So if I say that calcium chloride is -5 degrees Fahrenheit, that is a more precise description for the temperature of calcium chloride. I want you to pause the video and see if you can come up with an answer for this. So based on what you know, why is it that the liquid in a thermometer, when we put it in something hot, why is it that the liquid inside the thermometer goes up? Now, hopefully you said something about the molecules and how those molecules increase kinetic energy. As they increase kinetic energy, of course, they're going to expand, and there's nowhere for those molecules to go but up. So when we see a thermometer and the liquid inside the thermometer is rising, we say that that's a temperature increase. So the same thing happens to a balloon, a hot air balloon. If we want the balloon to rise, or we want the balloon to expand and open up, we've got to increase the air inside that balloon, increase the temperature of the air inside that balloon. Now, that's going to be something called Charles's law, which we'll talk about when we get to matter. I just want to plant that seed there. And most objects do expand when their temperature increases. Now, notice I said most objects because there are a few exceptions, but there are explanations to those exceptions. So a great example is a hot air balloon. If we want the hot air balloon to expand and then eventually lift, then we're going to want to increase the temperature of the air molecules inside the balloon. When those air molecules start to increase in temperature, they're going to start to move quicker. They're going to start hitting and colliding against one another, hitting and colliding against the walls of their container, which in this case is the sides of the balloon, and that's going to cause the balloon to expand. Thermometers work the same way. So you got that liquid substance. When you stick it in something hot, then the temperature is going to increase because the molecules of the liquid inside the thermometer are going to start to move faster and faster and faster, and there's nowhere for them to go but up. Same thing, if you take a thermometer and you stick it in something cold, it's going to slow the liquid molecules down, and when they slow, the liquid's going to contract, and so we see that as the temperature falling. So this just is another way of saying what I just said in the last slide. You may want to pause the video and just get this in your notes. It just explains the fact that as temperature rises, particles move faster, they gain kinetic energy, and we see a lift or a rise in temperature. Now, if we add energy to a system, you need to know that temperature will increase. So a lot of times heat energy and temperature are often mistook for one and the same, but they're not. Heat energy is dependent upon temperature, or vice versa. Temperature is dependent upon heat energy. So if we add heat energy to an object, its temperature will rise. If we remove heat energy from an object, its temperature will fall. So you can see in my examples here how that works. This is just a quick summary, so I'm going to go through this really quick, and then we'll end our lesson over heat and temperature. So remember, every piece of matter, solids, liquids, gases, are made up of particles. They're constantly in motion. This is called the kinetic theory. Temperature is a measurement, and it's a measurement of the average kinetic energy in an object. We know if kinetic energy increases, the temperature of the object will increase, so they're directly proportional. Likewise, if the kinetic energy of an object decreases, the temperature is also going to decrease. We can use qualitative measures like hot, cold, warm, lukewarm, cool to describe temperature, but quantitative measures are the best, and those are going to be numerical measurements that have units. And we're going to further talk about heat energy and how heat energy is transferred from one object to another in our next video. So I'll see you then.